Recording. So this chart, the characteristics of the base functions, this chart here is what we're doing today. So the parent function is y equals x, which we should know is called linear. I'm just going to go across like this. The x squared, anything squared, is quadratic. Parabola is the shape of it when we graph it. Quadratic is the name of the function. So it's a quadratic function. This is a square root function, right? And we know the reciprocal function. So all I did here was I plotted the points. We know those points. Here on this one, I would take off the word. I know it said integral here. It's just points, and I would list it. You don't have to list it at all. This was just a throwback from when we used to use the projector. We couldn't zoom in enough, and people were like, what point is that? What point is that? So we would just write it. So typically you don't have to list the points at all, just go ahead and plot it. Okay, that was just, again, a throwback when I couldn't zoom in enough that you couldn't see the points, but now it's pretty big, right? You can kind of see the points. So you can see all these points. Make sure when you're plotting it that I can actually see the points, right? So this is going to be nice and clear where the points are. Make the graphs as big as possible, so the same rules as before. Make the graphs as big as possible, show as many points as you can logically. So here, like that. So all the points are kind of highlighted there so I can see it clear. Now, for the domain for the linear is every real number. It keeps going up and down, so we are getting used to the integral notation. We're going from negative infinity to infinity, so it exists from the left to the right. Same thing with the quadratic, negative infinity to infinity. Yep.
Did you also write XER?
No, we're going to use not set notation. So set notation is the curly bracket one. So I want you to use this new notation that we have unless I say otherwise. So this one here, when you do x, and remember that little e means element of real. So that needs the curly bracket. That's set notation. So I don't want you to use set notation unless the question asks for it. We're getting used to our new notation. Okay, so fix all your notation. It's good practice. Okay, so let's practice it. So not set notation unless otherwise asked. So assume interval notation. This is called interval notation. Okay, so interval notation, so negative infinity to infinity, negative infinity to infinity. And then here, square bracket on the 0. So where is the domain? It starts at 0, right? Starts at 0, solid dot on the 0, square bracket on the 0 to infinity. This reciprocal function, we know that there's a split in the middle, so it's going to go negative infinity to infinity or 0 to infinity. I do want the x as an element of here, please, so do put that down, because then you're telling me the variable as well as where the interval is, because we have domain, we have range, it's going to go back and forth, so do tell me the x or y or whatever variable it is. This here, you can use the word or you can use this notation. That's the union symbol, which means or. It doesn't have a tail. Remember, it doesn't have a tail. It's just up like that. Okay? You can use either one. I'm going to try to use this symbol just because most of the university books will use that symbol. They don't use the word or as much. This is faster. Okay, there's another symbol for and that we'll learn later on, but that's the symbol for or. Okay, round bracket on the zeros because it never reaches there because it's split there in the middle. So the domain goes from negative infinity to 0 or 0 to infinity. The range is y goes from negative infinity to infinity for the linear. 0, including 0, right, starts the vertex at 0 and heads up, so square bracket. So highlighting the square bracket to infinity. Again, for the square root, it starts at 0, so square bracket, right? So again, square brackets, just highlighting the brackets, to infinity. Here, for the range, up and down, so it heads down this way and up that way, but there's a split in the middle, so that's why it goes negative infinity to 0 or 0 to infinity. In set notation, we said x cannot equal 0, right? But here in interval notation, you're saying which intervals it is. Any questions with that? All right, next row. X-intercepts. So the x-intercepts for the linear, 0. So I said x equals 0, so that's right there. This one, x equals 0. This one, x equals 0. None. Okay? And then same with the y-intercept. Y equals 0, y equals 0, y equals 0, but none. So y-intercept is where it hits the y-axis. Okay, for the end behaviors, as x approaches infinity, and we are using this notation. So this notation is the intro to the notation that we're going to be using in calculus. So remember that advanced functions easily moves into the calculus. If you're not taking it, it's still notation that you should know as a grade 12 student. Okay, so we don't want you using just the words. I don't want to see a bunch of words saying, on the right side, it goes up. You're going to say, as x approaches infinity, which means on the right side, y approaches infinity, y goes up. So instead of right and up, you're saying infinity, infinity. Infinity means to the right, as far right as possible, and infinity here means up as far as possible, right? So use the arrow symbol. Here on the left side, so as x approaches negative infinity, the very left side of the graph, y approaches negative infinity, it heads down. So it heads down. For the next one, as x approaches infinity, so on the right side of the graph, so again, we're looking at these graphs here. Right, so the right side, it goes up, and on the left side, it goes up. So both of them are approaching infinity for both, left and right. That means right side, that means left side, that means up. Okay? Here, as x approaches infinity, y approaches infinity, heads up. There's no asymptote there, it keeps heading up. It's slower, but it's still heading up. Never said anything about the speed, so it's heading up. Here, what we're going to put as x approaches negative infinity, sorry, I had a little glitch there to fix it. Blurred together, as x approaches negative infinity, which means the left side of the graph, so over here. You go, well, there is no left side. So you're just going to say y does not exist. Y, D, N, E. There should be a space there, but it's y does not exist. D, N, E. Okay, that's a D, N, E, right? Does not exist. One student before I made my D's wrong or kind of not as clear, and they said one, O-N-E. They thought I was writing the word one. It's not the word one. It's D, N, E. The letter does not exist. Okay? Then here, we're trying to be very specific with this. So as x approaches infinity, so the very right side of the graph, on the furthest right side of the graph that I could possibly draw over here, it starts to plateau to be 0. And to be more specific, it plateaus to be 0 from above 0. It's heading towards 0 from above. So I do want this here. I do want that, yes. And then here, as I head towards the left side of the graph, it's going to the left, it's approaching 0, but below. So that means above. So this means above. And this means below. Okay, you don't have to write the words that are in the bubbles, but that means above with the plus, and the minus here means below. Above and below. Okay. For the next part here, any questions with that? Okay. For the next one, no asymptotes, so put none. Oh, I do want you to fill in. So if we do something like a box, like sometimes we give you a chart like this and say fill in this box, this box, this box, don't leave it blank. If blank means you didn't get to it. You didn't know, you left it blank. If it's none, write none. Okay, so I do want you to actually write the word none in it. Don't leave it blank. If you leave it blank, it means you didn't finish it, you didn't know. I want you to write the word none. Okay, so none, none, none. Here, there is a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. Okay, and then the next line here, increase. So again, when you look at increase, do not follow the arrows. You're ignoring the arrows and you're saying, what is the slope of the line? It is positive the whole way. So that means the graph is increasing the whole way. Increase decreases the slope of the line. So it's increasing the whole way, so you're going to say negative infinity to infinity, and then for decrease, you're going to say none. For this one, don't look at the arrows, look at the slope of the line. This is negative sloping, this is positive sloping. So it's a new way of saying, but you're not going to use the word slope, you're going to say increase, decrease. So it's decreasing on this side, sloping down, increasing on this side, sloping up. Right? So think of increase, decrease as slope. Yes?
And there's a round bracket on the 0, so it doesn't actually, like, it's not doing anything with that 0.
Yes. When you're thinking, I'm heading downward, so I was walking down the hill and I churned. When you pivot, you're not increasing or decreasing, you're churning. So for any of these turning points, we're not including it as increase or decrease. We're going to leave it round. So yes, so it's going to be round brackets. Let's highlight that. Round, round. So it's neither increasing nor decreasing at that turning point. Now, for this one, people ask, why is it round? Because it's your starting point. So your starting point, you're not increasing or decreasing. You were just starting the graph because there wasn't anything to the left or to the right, right? So we're going to say round. It's not increasing or decreasing because it was your starting point. So where you start, you're neither increasing nor decreasing. You're starting, and then everywhere else after that, I was increasing and no decrease. Okay. Again, for the next one, don't follow the arrows. People go, oh, I'm heading. No, don't look at the arrow. Tell me the graph. Whoops, sorry, pull that down. The graph. The slope of this line is down, sloping down. The slope of this line, sloping down. It's sloping down for the whole graph, but there's a split in the middle. So I said increase, none, right? So increase is none, but decrease, it's decreasing all the way to the 0, round bracket, and then from 0 to infinity because it's not existing at the asymptote, so it's round bracket. Okay? All right. And then continuity. Okay, you don't need the graph so much anymore here. It's not so bad. Continuous, the whole graph is continuous. You never have to pick up your pencil. So it's continuous from negative infinity to infinity. Remember, usually, if I say the word discuss the continuity, technically you could answer either way. Tell me where it's discontinuous or tell me where it's continuous. So here, I said it's continuous from negative infinity to infinity. Here, I said it's also continuous from negative infinity to infinity. Look, for the square root function, I said it's continuous starting at the 0. So yes, it's including, because that's where your pencil starts. So my pencil starts at the 0 and then heads to the right. So including the 0, because that's where my pencil started, right? So at the 0 square, and then to the right. That's where it's continuous. Now, this one I could possibly answer two ways. I could say it's continuous, right? This is my reciprocal function, okay? I could say it's continuous from negative infinity to 0 or from 0 to infinity. Or I could have answered and said it's discontinuous at x equals 0. So if I say discuss the continuity, technically there's two ways you could answer. But if I say to you, where is the function continuous, you have to answer with the continuous one. If I say to you, where is it discontinuous, you would have to say discontinuous at. Okay, but if I say continuity, either one of those answers would have satisfied me, right? Because you discussed the continuity and you said one way or the other. Don't do both, because both of them is redundant, like you're saying the same thing twice. Don't say it twice. Choose one or the other. But if I said continuity, either one of those is good. That make sense? Good questions, clarification. Right. Okay, the next bit here is absolute, so I'm just going to slide over here. I'm just going to zoom out a titch. Absolute max. Now, the absolute max, the reason why, because people are like, maximum. Why do you saying the word absolute? Later on, and again, we start to get you used to the proper wording now. Later on, what we're going to do is we're going to have graphs maybe like this or like this. So on a graph like this is kind of like a max, but it's not the absolute max because it keeps going. So we use the word absolute and locals. So this is a local maximum. So if you were climbing a mountain, you'd be like, oh, I climbed the mountain, I got to the top of this mountain. Then you go, okay, but was it the highest peak? No, because then it kept going over here, right? So if you were, say, climbing these two mountains, this would still be a maximum, the maximum of that mountain, but this is the absolute maximum peak of both of the mountains, of the whole graph. So this is called an absolute max, and this one is called a local. And they distinguish that later on more, so we'll talk about that more later on, but for now, they start to introduce you to the word absolute. Absolute means the complete and total highest point on the entire graph completely. I don't care about the little maximums or minimums that may happen, just the absolute maximum or minimum point, okay? And so that's why they use that word absolute. People are always like, why absolute? Isn't it just max min? So it's being a technicality. So we're going to clarify that. Also, when I talk about the maximum point that you climbed, you always give me the height back, right? So if I say, what's the height, what's the maximum height that you've ever climbed? You give me the y value. So I want the y value. People say, is it a coordinate? No, it's not a coordinate. It's just the y value. If I say, what's the maximum value or absolute max or min, we're talking y value. So none for the linear, quadratic none because it keeps going. The square root, none, because it keeps going. None for the reciprocal function, because it keeps going up. Here, none. Yep.
Yeah, everywhere where you put none, I put infinity or negative.
No,
infinity.
not the same thing.
No?
No. There is no maximum. So just put none. Yeah. Okay?
So why can't it be infinity? Like what does max mean?
Max means would like the y value.
Yeah, so wouldn't the y value be infinity?
But it's not a value. So why are you giving me infinity? Because it's not a value you're going to ever reach. So you're kind of being...
But we use like infinity.
No, that's the
interval
approach.
notation.
So that's the approach. Where is it heading? So I'd like to know where it's heading, but what's the y value? There is no y value. So be more specific, there is no maximum point. It keeps going to infinity. So N behaviors is already discussing that, so I'd like the word none. Okay? So here you're going to say 0. Y equals 0 for the minimum point, right, when there is a minimum point, and this one y equals 0 for the minimum point. So when you can, you're giving me the value. Okay? Odd, even, or neither. I should have put the word or neither there because it's one of the answers you could put. This one we know is odd. We've discussed that already, right? The linear. The even function is the quadratic when it's reflected left to right. And neither for the square root function because you cannot, right? And then here, the reciprocal function is odd, right? So remember, odd means if you do the vertical and then a horizontal, it brings it back. So the reciprocal function is odd. So again, think of it this way. You're doing a vertical reflection and then a horizontal reflection. So it is odd. Or you can do a horizontal and then a vertical. It brings you back to the original. So this one is odd, neither, even, and odd. Okay, next page. All right. The name of it, we know exponential, sine. I just did sine, not the cosine, but again, I could ask the same question with cosine. It answers slightly differently. I'm going to show you sine, though, and then absolute value. I did my points again, and like I said, you don't have to list the points. It was just in case you couldn't read them, but I think you can, if you zoom in, you can read all my points, and I'll scan it as well, so you can see the scan. Yeah.
The sine graph, do we call it like a sinusoidal graph for sine or cosine?
Sinusoidal means it could be sine or cosine, though. So this one specifically is the sine graph. Yeah. Because sinusoidal, remember, counts for either sine or cosine. It means it is that same shape. So use sine. Yeah. Domain of this one is negative infinity to infinity. The sine function actually keeps going forever. I know this is the only one that we don't put the arrows on. The reason for that is because the arrows look strange when you stop at a certain point, because you can't tell if it's supposed to continue forever. So if you were to stop at a maximum point of a sine, so if I had this period here like this or a cosine and I put arrow, it kind of looks like it's continuing forever. So we typically, it's kind of standard form that if you're doing sines and cosines, you don't put the arrow because it's more distracting than helping at that point. It looks like it continues forever and you kind of go, which one is it? So that's why the sine and cosine, we never told you to put arrows there at the bottom because it looks kind of funnier. Everywhere else it should be arrows on there. So that's kind of a standard form for sine and cosine. So you know sine and you don't put the arrow. So everywhere else it's got the arrows.